So before we start, some announcements. For this month, there is the ETH Online Hackathon and Summit that is happening starting tomorrow, all the way until the end of the month. Since the whole COVID thing is happening, there's no DevCon this year, and this is probably the closest thing we'll get. So it's actually a benefit to a lot of people who wouldn't necessarily have been able to travel all the way to DevCon. They can participate online. There's a hackathon, which I believe still has a window open. I might be mistaken. So if you want to participate, whether you are a technical person or not, you can feel free to do that. And they will actually match you up with other team members who can complement the skills that you have. Other than that, there's also lots of summits. I believe every week there's a different theme to the talks. You can check it out at their website. And yeah, just register and then you'll get updated as to all the talks and events that's happening as part of the entire month. Then we have a quick roundup of stuff that's been happening this month. The very first one, as mentioned slightly earlier, is everybody should be familiar with this by now. Anyone who had ever used Uniswap, even if they made a failed transaction, would have gotten at least 400 uni, which at the time of launch was worth $1,200 each. So please check your Uniswap, any wallets that has used Uniswap before, just in case you are able to claim. And if not, well, that's unfortunate. Slightly interesting story is that earlier this year, I remember running a ETHKL meetup where we just tried out different decentralized apps, including Uniswap, and things like Loopring and Tornado Cash. And so I created a wallet and I spent some amount of Ether to pay for gas, which at the time, people were fairly kind of sad that I was spending that much in fees. But fortunately for me, because I created a new wallet, I got an entire 400 uni just from doing that educational meetup. So it was probably like a multiple of 10x reward for doing the education stuff. Next, we have Escaping the Dark Forest. So this is a blog post written by Sam Zun. I hope I'm pronouncing his name right. A very sort of popular security researcher in the Ethereum space. So you should read the entire blog post itself because it's essentially like a whole Hollywood movie. But essentially it was there were about almost $10 million worth of Ethereum stuck in an address, which could have been drained by anyone. So a bunch of white hat hackers went and saved it to be returned back to the original sort of owners. But learning from another recent attempt, which the first attempt actually failed because they were front run by bots. So these guys did a very elaborate scheme to get around the front running bots so that they could transfer that $10 million safely. And yeah, it involved a lot of people all over the world at weird times of days for a bunch of them. Third one is EMN. So this just happened like a couple of days ago. I hope no one here dumped too much money into EMN, and hopefully none at all. So as the story goes, Andre Cronje, the founder of Yearn, has been building this decentralized NFT game. And he is popular for testing in production. So he created this contract. A bunch of people found it and got very excited. So they started depositing a lot of money, $15 million worth of crypto into this unfinished, unaudited contract. And at some point, attacker exploited a vulnerability and essentially drained all $15 million from that contract address. And afterwards, he or she very kindly returned $8 million back to the address, which has led to all kinds of theories about why it's been done. But yeah, so the lesson here is please don't be greedy and put money into contracts that may potentially lose all your funds. And if you do want to be greedy, then just make sure you don't put in any amount that you're not willing to lose. Moving on to some local news. This is kind of frequent stuff that we see nowadays, but it came up last month that there were about 100,000 ringgit. That's about roughly 25K USD. That has been um, stolen from sort of electricity from other people, and this is in Sarawak, and it's been going on for a few months, and they were finally caught recently. Yeah, so that's just something that's happened. We also have two stories actually of sort of big publicly listed companies in Malaysia who are dabbling in crypto. So for those of you who remember the horse currency from, I think, a couple of years ago, so Country Heights, their founder and I believe chairman has stepped down to focus purely on this blockchain venture. The Country Heights itself wanted to do this, but they were essentially blocked by regulators. And the founder has essentially sort of stepped down so that he can run an independent subsidiary that can work entirely on this project. And as I understand it, they plan to be the first publicly listed Malaysian company to accept Bitcoin and Ethereum for their services. And another related one is XOX Berhad, which is a mobile telco, have announced that they are creating this end-chain powered blockchain to do traceability as a service, essentially using Internet of Things devices to track sort of movement of items and putting it on the blockchain. We have Dominic here today, so maybe he can expand a bit more on the sort of how much of that is something that blockchain can add value to. For someone like me, I've always been very curious as to how any of this is, how much of this is real value and how much of it is based on the whole hyped buzzwords of IoT and blockchains. But yeah, so that's pretty much a monthly roundup for this month. We're at just before 8:15. So next, I'm just going to introduce Dominic from Diode. Dominic is the CTO of Diode, and I guess I'll just let Dominic introduce himself next.
Yeah, hey, thanks, Harris, for that. That was really interesting. I'm curious about what the telco is doing there with blockchain. I can share my screen in a bit, and then I can talk a bit about what I've been doing. Let me see, I try to share my screen here. Just tell me if you can see that. Awesome. Yeah, so I'm Dominic. I'm co-founder and CTO of Diode.io. So we are a blockchain startup. And before that, I was working in an IoT company in Taiwan. And before that, I was working at Nokia and also doing IoT, like the old mobile phone maker. So I got around quite a bit there. And just a little bit more about us. So we have this, we work based on Ethereum, and we have an Ethereum fork that we're using to implement BlockQuick. And this is really, we started out with a IoT background. So, and we wanted to see like, hey, how can we actually take like a light bulb and connect it to the blockchain? How do you actually do that? And then we found by trying out that if you try to use Geth or you try to use IOTA, like you need to have a lot of capacity on these very small devices. And so the top right here, for example, in the fingers, that's like an ESP32. It's a very popular Chinese chip, but it only has 2 megabytes of RAM, right? So it's very, very small. But so if you want to sync like with any like other client like IOTA or Guess, you just blow it up. And so this is where we went in, and because of that created BlockQuick, so we can connect to the Ethereum network. This is what we launched, this is what we build on. You can download the client today, and I want to talk though a bit about what we think of the IoT space, right? So this is some of the demos we did. We have some video streaming over the blockchain network. We have end-to-end encryption. We have a secure time consensus app, so actually having a device get the time from the network. We have built a VPN client demo to make like a anonymous blockchain-based VPN network. And we also built a developer tool. You see that in the bottom left, ngrok on blockchain. So it allows developers to make decentralized websites and publish them out to anyone on the planet who wants to see them in a decentralized fashion, like from the computer under your table, basically. And of course, there's a network explorer that is mostly what has Ethereum, but plus like IoT additions, like a map view of the network, and then different concepts that we introduced. But let's go back to IoT and blockchain. I think the first reaction, if somebody tells you IoT and blockchain, is like, you should take a step back and say like, what? Like, why should I care about like this thing called blockchain, and why should I care about this thing Web3? And especially from a business perspective, often the reaction we see is like, they care about making revenue, right? So like, what is the thing that helps me to improve my revenue here? And so this is a chart I really like, where we look at like this. If you think of a company, right, it has certain wants and things it wants to achieve, and it has needs, that things it needs to do, and pains, like existing open problems. And a business is always interested in like solving one of these problems, which all are focused on the business. But it's really hard for a business to say like, hey, there's this new thing from blockchain and you can send money from A to B. And they say like, but we don't need to send money from A to B. You know, we have a light bulb and it needs to like turn on and turn off. So we need to fit into this triangle here for companies. And so I've put here left and right some of the use cases that we know from the blockchain space, and some of the use cases from the IoT space. And on the blockchain side, I think it's pretty clear. We see digital identity, of course. Like everybody here probably, I guess everybody here probably used MetaMask at some point, or some other tool, like just to interact with Uniswap. So there definitely digital identity is there and something we can use. And there's supply chain, voting, fundraising, notary, food safety, and of course DeFi, like banking on the blockchain. That is a big use case. And on the other hand, IoT has like quite a couple of different ones, and we need to find the overlap between them. Now, I want to say that's my personal opinion. There's certain there's a couple of attempts to take like blockchain use cases, for example, like some of the banking, some of the actually sending money and moving that to IoT. And in often cases that's actually not a need that IoT has, right? So if you look at your drones, for example, your drones do not necessarily need to send or receive money. Often it's like the user of the drone who's doing that. But we believe that there's another use case that is here in the middle, right? We have the blockchain strengths, we have challenges of the businesses, and we have the business needs. And we need to find this overlap, like where's blockchain really good and businesses really want to have it. We believe for us, the answer is security, Web3 security, blockchain security, security aspects that the blockchain can bring. And I want to talk about that because this goes back a bit to like incidents that we are seeing in the like every other week. So this one, for example, I don't know how many have seen that in the community, but this was a couple of weeks ago when Twitter was taken over, and all these Twitter accounts suddenly started to tweet out these really silly crypto scams, like, hey, I'm Joe Biden and I'm giving out Bitcoin to the community. Just send some to me and I send you back, right? And what here happened, the security incident, is actually pretty interesting. I want to talk about that for a second. What happens here is that Twitter, and like any other company on the planet, so what they have is they have some support staff, right? There are some people on the phone And you can call them and you tell them, hey, I forgot my password. Can you please reset my password? I'm really Elon Musk. Can you please reset my password? And if you convince them that you are Elon Musk, they will have the power to reset you. And you have that in every company on the world. It's called the principal agent problem. So these support guys, they are not Elon Musk, but the support guys, they have the power to basically take Elon Musk's Twitter account, right, and do with it whatever they want. And the same is true in any other services, really. In Facebook, for example, there's Facebook support people who have the power to do everything with your account that they want, right? Just because they are on the admin side of it. They're somewhere in this data center, they're sitting there and they're able to make these modifications. They have some direct access, usually to do good, like to help you reset your password, but effectively they have the full access. And this creates a problem that you just trust them, right? You're the principal, you're the customer of Twitter or Facebook or any other service in the web. And you trust that there's some agent, like in the support, and they will not act out of self-interest. They will only do what is good for you, and they will never take your identity and do something crazy with that. And we believe that this principal agent problem is actually a perfect fit for blockchain because we can solve it. With blockchain technology, we can actually replace the agent in many, many cases just with a smart contract. We don't need a support person to reset your password if we can have like social recovery, for example, where you have a multi-sig wallet, and that multi-sig wallet you can use to ask like 3 of your friends, can you confirm I lost my password and reset it? And so this automation can actually apply to many, many cases. And in the future, we don't need the support staff to be able to reset Elon Musk's password. In fact, it's so silly, I think, if I think about that, like, at least you should have a system where you say, like, if there's a support person who can reset passwords or accounts, there should be like 2 or 3 people needing to also approve it, you know, like in a multi-sig. Especially if it's an important, like, if this is the president's or the vice president's Twitter account, you should have multiple levels, right? And of course, with a smart contract, this is super easy to do. And you can actually prove that really nobody else can just do it. You always have to go through the steps if it's multi-sig. And so we're gonna take this, and we actually believe that this is applicable through like a lot of industries in IoT, but also even in like the normal web. And so one of these cases here is the principal agent problem in PKI. So this is just your daily internet connection. You go to https://facebook.com, and then Facebook tries to open encrypted connection to you. And so what's happening here is, actually, if you ever click in your browser and this top left icon, there's like a little lock icon, and look at that, and it will show you a certificate, and it will show you that the certificate has been signed not by Facebook, but by somebody else. It's called an intermediate certificate authority. So usually it's Let's Encrypt or DigiCert, they're quite big, but there's actually many of them. And there's many of them that are just like small individual companies. But we trust all of them because as long as they sign the certificate, your browser will accept it. In fact, your browser does accept roughly 3,000 of these different intermediate companies. So this is some of them. You can actually publicly query that. I have a link here. It's not clickable as you can see it now, but maybe I can put that in the chat. I can do that in a minute. But you can check that out. So there's some companies you know, like Let's Encrypt and DigiCert, but there's also companies that you don't know. Like basically in every country on the planet, there's such a company. And they have the ability to create a valid SSL certificate for everything, like for every domain on the planet. And so you not only have to trust one of them, you're effectively trusting all of them, right? And not surprisingly, I was just curious about that on the right-hand side. You can see like the distribution. Most of them are in the Western world, like tons of them are actually in the Western world. But there's, I think just because of the history of the internet, but there's, it's growing all over the place. And this is what happens when somebody actually creates a certificate who is not the one you think be. So this was actually half a year ago in Kazakhstan, when the Kazakhstan government decided that they actually want to read all internet traffic from the citizens. What they did is they created fake certificates. So this on the left-hand side, we see the correct certificate from Facebook at the time. So we see it's the name's Facebook, and it has been down here. It says CN, which means Certificate Authority, and it's DigiCert. And the country of DigiCert is US. And then on the right-hand side, we see the certificate that was delivered if you lived in Kazakhstan. You would see a CN, like a certificate authority called the security certificate. So they just made that name up. And the country of origin was Kazakhstan. So they created this certificate, but every browser would say like, this is valid because it's signed by one of the intermediates that your browser trusts already. So this is a typical principal agent problem. And this is not, it's not bad intention by anybody. It's just like the technology, when it was created before we had blockchain, there was no way to make a central database, right? There was no way to make a central database that everybody can access and that is always online. So the only way they could really do at that point in time is create these hierarchies of trust. But today we have blockchain. And so we're actually suggesting, and we're using decentralized PKI in our product. And DPKI means we're putting the certificates into the blockchain and the DNS names also into the blockchain. So they're living both there. And now if the user browses to facebook.com, or would in this world browse to facebook.com, they would only contact the blockchain to check, hey, I want to know who owns the facebook.com domain. And you get back like an Ethereum key, like an ENS. And then you can check like, and what is the correct certificate for this, also from the blockchain. And then there's no third party involved. Nobody who can like inject anything else. And you don't need to rely on the trust anymore. So the man in the middle attacks become possible. This is the second item we show here. Like we talked about Twitter and the support people, and the support people were an agent. Now we're talking about PKI, and we see that we have these intermediaries and they're an agent, and we can also remove them. And the business case, if you do this in general, is actually pretty clear. Like, of course, it becomes more secure because you remove like some of these intermediaries, but it's actually also easier to be compliant because now in Europe, for example, we have this GDPR, which is a Data Privacy Act. So companies have to show that all their data and everything they do is trusted and within country limits, right? Like I want to ensure that the data of my customers cannot leave the EU, for example. And it becomes actually in the systems we have often really difficult because there are so many intermediaries. But if you remove them, it becomes easier to prove who's involved and who's not. And then very important for businesses, reduce costs, right? If there's less agents involved, there's less people you have to pay. So it's very easy. This is pretty technical here, but I wanted to show that on like the typical way, like an IoT device. And this might be the light bulb, or this might be maybe a robot you have, or like a smartwatch, what they usually do. And looking at that, how it is today with PKI and how we believe it should be in the future. And this is like, it's code from like the C language, I don't know how technical people are here, but there's basically a couple of steps that you always need to do. The first thing you need to do is like, you need to get the time as a small IoT device. And surprisingly, that is actually not very easy to get. For a human, it's quite easy to understand the current time because you just walk up to the next clock and you ask 3 other people, and then probably you're going to get the real time that it is right now. But for a machine, getting the time trustworthy, like knowing that the one who's just delivering you the time is actually the one he says and it's the correct time, can be very, very complicated. It's effectively unsafe. Then you try to make a lookup of like, I want to connect to my hometown. Like, so we had, for example, this puppet that would be able to be a baby controller. So it's like a baby phone, and you can put it in the baby's room and it acts like a microphone. So it needs to connect to some server. And you want to ensure it actually connects to the right server. But today, as we discussed, they're using these certificates, and they're often using unencrypted DNS. And so also that lookup is not safe. And then finally, they're checking the certificate, and we just talked about that, and it's also unsafe. And then on the right-hand side here, we have how it could look blockchain-based. And like this time problem we solved, because if you know the peak of the blockchain, like the most recent block, it actually has a timestamp. So we know the time. If you know like an ENS address, you can look up in the blockchain, and with the Merkle proof, you can prove like this is correct. And so you can get the certificate and you can connect. And the whole path we can actually make end-to-end secure. So it's something completely new to the web. That's why I like the term Web3 actually, because I think there is potential for that as like Web3. And just be with me one more second here on the technical parts. I just want to give like a little side rant here on Infura and a lot of people who use Infura, which is they're doing a great service. And it's awesome that they offer like Infura for free for everybody to make your little Web3 experiments, but they're becoming an agent as well. Like everybody is trusting Infura when they use like web applications. Like even MetaMask is actually trusting Infura. They don't, because the user is not doing their own validation, right? The validation is not running in your browser. The validation runs on the Infura side. And so everybody is trusting Infura. It's great and it's cool for adoption, but it's an agent, right? So just be aware of that. And so where we wanted to go to is like getting rid of that, right? Getting rid of the HTTPS and getting rid of the agents. And so that's where we did BlockQuick on the right-hand side here. So I would like to go a bit through like some, and it's always the same pattern here. It's some of the attack vectors that we have. So we always have this agent problem. And in many, many cases, this is what we're talking about here. So this is a typical company that does some IoT product. We call it the enterprise. They have some admin staff. They have some servers. They have some connectivity down there on the right-hand side, like the router, and then there's some device. This is our little yellow robot that hopefully is doing what we wanted to do. And then on the left-hand side, we have the core internet infrastructure that has routing, certificate authorities, DNS servers, NTP. And all of these are attackable. And they're like from least, like the easiest to attack to harder and harder to attack. So $1 sign here means really easy and cheap to attack. Like the cheapest to attack is the call we just talked about. Like, hey, I forgot my password. Can you please reset it? And then it gets more expensive. Like you can attack a server, try to like make a denial of service attack. You can do man-in-the-middle attacks and so on. You can try hacking actually devices directly, but for that you have to find like the intrusion points. And then you can like go on the left-hand side from bottom upwards, like NTP, you can try to change time with man-in-the-middle attacks, change DNS servers, take over certificate authorities, do BGP routing. And so we want to show here just that actually all of these problems that are happening like weekly, really these attacks, are solvable with blockchain. So Twitter actually, after this incident, they confirmed, hey, we detected the issue and we found it was actually social engineering. So it was in fact some of the support people. Either they were blackmailed or they were called, we don't know, but somehow they got in through some of the support people into Twitter and could take that over. So very clear, if you replace that with smart contracts, like this problem is just gone, right? This is, you can actually, as an industry, you can just remove this problem. Then we had, shortly after Twitter, I don't know who saw that, like Garmin was down, like all of Garmin was down, and they had a ransomware attack. They're up again, I think, right now, but they couldn't recover all the data, but they actually had all the servers down. And what happened to Garmin is they got ransomware. So it's like you open an email and there's a like little binary in it, and that will encrypt your whole hard disk. And then for some reason, it was able to go from there to their servers. And they did never explain like how that did happen. But somebody in their office installed the virus, and then the virus spread into their servers. Also this, like if you have a central server, that's always the issue, right? Because for the central server, somebody has access to it. You have an IT admin, he has access, and you have like this whole operating system, like Linux or Windows running around this. And if Windows gets infected with a virus, like your program will not be able to run anymore. Like they can shut you down, they can do whatever you do. But if your program runs on the blockchain in a smart contract, you have to try to infect the blockchain with a virus, right? And this is much harder. So the attack vector like nearly dies out. I want to be fair to everybody. So I said like, there's still like, in theory, you can do a 51% attack, of course, right? On blockchain, you can always do the 51%, but it's much, much harder than sending a virus email to some random dude, right? Now you suddenly have to like hack the whole network before you had like hack one guy's computer in the whole company. And then we talk about man in the middle. So there's actually so many of these ransomware attacks today, right? I just wanted to, this is, I took the snapshot just from last year. This is actually exploding this year. I just didn't have the time to make a good summary of that for now. But especially in the US, what they're doing, these hackers, is that they found that sending an email as a virus works pretty well. They're doing that on all kind of different governments. So local governments, local city governments, they're sending the local city some virus, and then they ask like, you only get your data back if you give us this money via Bitcoin. And so they're all having this problem, and it's just like, because hackers make money, and if you make money with a business, you realize that your business idea is good and you invest more, and so you attack more. And this is right now going crazy. Like cities are being attacked like never before. And probably we have to say, like, as crypto, I hope we can be the solution with Web3, but for now we're also part of the problem, because Bitcoin is like the way all the hackers get the money out, right? So we think we can solve that. We think also we can solve most of the man-in-the-middle attacks where people are intercepting traffic. It's still happening like everywhere in IoT, that devices are communicating without encryption. You get the data, you access it, you send wrong, like you send a virus, you send some wrong data. This is not necessary. Like with Ethereum private keys, you can actually not only do sending transactions, but you can establish secure connections from one end to another end. So if I use my ENS name and it looks up to an Ethereum address, and my, let's say Harris is using his, I know his Ethereum address as well, then we can establish on a technical level like an end-to-end encrypted communication channel just based on Ethereum technology. And so this is what we do as well, with nobody in between. And then of course, at the end, network control. So right now, if you use like the standard internet, there's a lot of open ports, there's a lot of communication that can be hacked and cracked. And if you change those through a Web3 interface where everything is authenticated, because everyone on everyone on the Ethereum network who's interacting has an identity, right? So you basically have no anonymous access anymore. You can like, Harris is shaking his head, like anonymous in the personal term, of course you have that, right? You don't know names, but you always have an ID, right? You always have an ID. And so it's very easy for IoT devices to say like, I want this device, my puppet, to be controlled by this and this and this ID, and everything else no. And you can do that on a network level. And I want to fly about this because I don't want to like take too much time here. But we talked a little bit about time, that this is actually a problem. I just want to show this. Like you can check this also in your browser. Actually, if you click on the lock, there's always like this view certificate, and you can look into that. Like every certificate that exists and that protects your internet browsing has like a starting time and an end time, like this one, for example. This is from our call. Just before I entered our call, I checked like the certificate from Zoom. And so it's using a certificate that's valid after May 2020 and until like 2 years from now. And that's great. And so for us as humans, it's very easy to see that, well, this is valid because right now we have 1st of October, and so this is within that time frame. For a machine, it's not that easy because it first needs to know the time, right? So especially if you imagine the first connection, it is a chicken and egg problem. I need to get the time from a time server. Of course, this is what you do. But how do I know that the time server is truly the time server I want to talk to, right? The time server is going to send you a certificate and say like, I'm the time server. And in that certificate, it says not valid before and after. And you're like, yeah, but I don't know the time, right? And so there is a chicken and egg problem that hasn't been solved without blockchain. And with blockchain, because we can get the time from the most recent block, we can solve this chicken and egg problem actually. This has caused so much trouble on real deployments already. For example, the Oculus AR headsets that you can use, really cool devices, they had this problem that they would not auto-update anymore because the certificates would expire. And then nobody could use them anymore. You had to regularly replug them to your computer and reset them. So we can solve that. We can solve DNS with blockchain name service, like with ENS or other variants of that. This is just another example. Just I want to show here examples of like everything that we think we can fix is being attacked in like the normal Web2 world today. So this, for example, is a hack that happened 2 years ago on customers of a bank. So they took over the DNS name, then they put themselves in between the customer of the bank. The customer thought he's talking to his bank, but he wasn't. And then he clicked like, make this transfer, I want to do a bank transfer, but actually they were sending the money somewhere else. And this happens through DNS because of the way that how DNS is being used to validate correctness. So you can use Let's Encrypt if you have control on DNS to get a valid cert, and then you can use that to intermediate people. And the way they got in between is actually an IoT attack because they got on the customers' routers in their homes. So we can fix that. ENS is actually working on that as well. Smart contracts, of course, we can replace the weak factors there. And then there's like this last item that is really hard to track. It's like the lowest level of the internet infrastructure right now. It's a BGP routing. So if you send like a packet from here to another location on the other side of the planet, there's like an automatic decision making on how the packet is actually arriving at its destination. And it's malleable right now. So you can actually impact that. And we know that this is being impacted. This is like an Oracle report. It's a report from December 2015. It was like one of the first times they detected it. And they tried to send packets from Los Angeles to Washington, right? Like data packets, TCP, and just make a normal open a connection. And what they realized is that for some reason, these data packets from Los Angeles to Washington, DC did not go through the US. They left the US. They went to Asia, made a hop in Asia, and came back there. And that was actually a routing attack. So these routers in Shanghai, they announced, well, I have the shortest route to Washington. Here, send the packets to me. I have the shortest route. I'm the cheapest flight. Come to me. And so the packets, because it's a totally autonomous system, BGP, went over there and then went back again. And so this is something that we're still working on. But our belief is that because we have end-to-end encryption, even though you can reroute it, like a big player like that, you can still not read it. And so I'm coming to the end here. This is why we believe actually the #1 use case for IoT and blockchain is increased security. Like is making security simpler, is making systems simpler and making also systems sometimes cheaper, and removing this principal agent problem in so many companies. And it's not only applicable to IoT, it's, as I said, like it's Facebook, Twitter, all the social medias they can actually make their businesses cheaper and more secure this way, if you think about that. So we looked at this in the beginning, so I wanted to look at that at the end again. Once, like lower cost, every company wants to have lower cost. They have needs, security, obviously, and now pains. I want to raise that because this is actually something that we see when we talk to companies. They are ultimately afraid of tokenomics. Like companies, when they hear blockchain, they hear that and like, whoa, maybe this sounds all great, but if I do this, maybe I get regulated by the Fed, right? So they're really afraid of this. And this is something that we as an economy and a community, we have to work on to also take the fear from the companies and show them the ways this can work. This is some of our next steps. It's very technical, so I'm gonna skip this. If you're curious, you can go to our website and check out, there's some of that. If there's only 2 things to take away from this, like if you can remember 2 things from this, remember we are the guys who did BlockQuick. It's like the first nano client for Ethereum networks. And we as a community, as an ecosystem, we have to decentralize the admin. We have to get rid of these IT admins, of these support people that have all the power. because it doesn't make sense, and it's a super big security issue for everybody. It's a human factor, and like, who can impersonate the president, who can impersonate Elon Musk, who can impersonate you, right? And it's also a problem if you work with centralized exchanges, right? You don't know who else actually has access to your funds or could do something weird with that. So we have to solve that for everybody inside and outside of crypto. And that's it, really. I'm happy to answer any questions. You can actually, like what I presented, you can download our software. Right now, it's a pretty technical piece of software from Diode.io. There's a /downloads, and it's a CLI, so command line tool for IoT devices. You can download it and play around with that. If you have a Raspberry Pi, that's like super easy to do. And just have fun and let us know.
Cool, thanks. Thanks, Dominic.
Hey.
So yeah, we're opening the floor for any questions. You can either type it in the chat or just unmute yourself and verbally ask. In the meantime, I had one right at the very end there on BlockQuick. To be honest, I'm not entirely familiar with BlockQuick as a light client. So I know it's a bit off topic, but could you elaborate more about like what BlockQuick does or did, and especially now with Ethereum getting more and more bloated, how does BlockQuick cope with that?
Yeah, sure. BlockQuick is actually a pretty simple idea. So the problem with a lot of light clients or like other clients is that if you want to validate the whole blockchain, usually it's a lot of effort and it's a lot of traffic, right? So I don't know how many of you try to run a Ethereum node, but you know, like that getting over the syncing is like the major pain, right? And if you try that on a desktop, it's a major pain. If you now imagine you have this tiny, tiny device, it's like nearly impossible. And so there is a couple of these approaches. There's actually another algorithm called FlyClient. And FlyClient and BlockQuick, we looked at how we can get these very small devices to somehow leapfrog that validation. And so what we're doing in BlockQuick is we're using actually the ratio of all the miners as a way to jump the validation. So if you go to Etherscan, for example, you can see that there's a distribution of miners. Actually, I'm not sure. I don't think I have this as a slide, but there's a pie chart of miners, and you can see like 30% is this guy and 30% is this guy and so on, right? So and these people are basically, you can see like how many of them you need to know like this is 51% approved. And so this is what we do, and in essence, the client is checking whether there's 51% of these people present who approve that this is the valid block, the most recent valid block. And then based on that, we take a snapshot of this pie chart, and we have an algorithm to extend that, right? So incrementally say like, because they're not always staying miners, sometimes the ratios change, right? We can update it over time in a secure manner. But that is the essential idea of BlockQuick, right? Given you know this pie chart, you can check, well, this most recent block, has it been approved by this and this and this and this guy? The way we do that is in blocks, you always have like the miner today, like you have the Coinbase, who is actually the miner. Today though in Ethereum, like in the default Ethereum client, that is not a signature, not signed with a public key signature, but it's just put there. So anybody, like you can put like somebody else's Coinbase there, and then it looks like you had created the block. In our case, we ensure that it is a signature, so nobody can like impersonate some big miner. And then the existence of these miners tells us, well, that we are still on the valid chain, right? Just to make it very plastic, like imagine you're on a fake chain, so somebody wants to give you a fork, like the light bulb. The light bulb is a poor small device. It's living in your home, and it only has connectivity through your router. Now you go to your router, and you show the light bulb basically a different internet where it can only see your fork, like your personal fork. The problem with your fork is it was like following Ethereum quite some time, but then suddenly from some point in time, every created block is created by you, right? By one identity, which is you. And now the light bulb looks with BlockQuick at this and says, well, I see more blocks, but none of these blocks are from the 51% of people who were actually creating blocks before, right? Something is wrong here. I'm not going to believe this. I'm not going to believe that all the blocks were created by this pool of many, many people, and now suddenly it's only one person creating blocks. And this is where then BlockQuick realizes this is not the real chain. This is a fake chain. And this protects you it actually also protects you from all kind of 51% attacks that we have seen, right? Because what often is happening there is that there is a single entity, like one company or one evil guy creating 15 blocks, right? Out of nothing. Before he was never active, and now he creates 15 or 20 or 100 blocks, so the exchange believes him. But with this kind of system with BlockQuick, that's also not possible, because they all would see, well, it's all the same guy who created these blocks. It's not the real chain. So that's the essence of BlockQuick. It's actually pretty simple if you think about that.
Okay, cool. There's a question here. I guess kind of the obvious question is, with all the sort of decentralizing the principal-agent relationship, would governments be okay with what Diode is doing as a solution? And
I think so. Yeah, I think so. I think actually I hope that this is actually going to be a happy blast for governments. I think that governments are often like protective, right? And so they want to protect their users or the citizens. And I think one problem that we're also seeing like right now in the US between TikTok and the US government is like, of course, you could I think it's mostly a positive problem. What they are realizing is that another government has access to our residents' people, right? And this is what they're saying. And this is a problem for them. Now, if Diode comes in or some other decentralized solution, you can always prove actually no other government has access to it. Nobody has access to it, right? So it's like, it's peaceful, neutral data. You can prove that nobody has access to it. And if nobody has access to it, then there's also no reason for this worry. And I believe actually that this is one of the biggest drivers. In Europe, for example, the new data privacy acts. In Brazil, we have new data privacy acts. In the US, we have the new policy. But they're always starting because they realize a different country has power over their own residents. And I think this is actually where blockchain can help us save the internet, really. I think this is all about saving the internet, because I'm afraid that in 20 years from now, I'm going to tell my children, like when I was young, we had the thing called the internet, and you could browse from one side of the world to the other side, and you could read news from another country, but today you can't anymore. Because what I'm seeing is that the internet is fragmenting, right, into so many national bubbles. You have the Chinese internet, you have the Russian internet, and maybe in a couple of years, you have the European internet and the US internet, right? And even like every country is starting to do that, because they see they lose this control to other countries. And I think that's the danger. But if we can make blockchain the platform, then, and we can show that nobody owns it, we can really go back to some of the previous thoughts of the internet. Like this is its platform and nobody owns it. And then I think most governments are much happier to work with them and let their residents have them as well.
So
this is my, I hope that.
Yeah.
Go ahead.
So to kind of on a slightly different note, and this is more general kind of question, because I guess it doesn't just apply to Diode or IoT devices or solutions, but so when you talk about how you want to have like multiple parties to provide identification if people lose access, to have some sort of multi-sig structure. Have you thought about explored more on like how to make the process easier if suddenly like multiple nodes or multiple wallets in the multi-sig go offline, or like in the real life terms, like if people pass away, how do you ensure that it can still continue to function smoothly?
Yeah, I think we're focused actually somewhat on the business cases. And so in the businesses, I think there's often like the multiple nodes would actually be other companies often, right? So for a lot of these IoT companies, we believe that it makes sense to have like this kind of backup way, right? To say like, if I lose my password, if I lose my data, or even worse, if I'm being attacked and somebody is stealing my private keys or something like that happens, I need this backup method. But it could be then that the company is choosing those 3 or 4 or 5 other companies that they trust to. Might be a bank, you know, like if it's a company, they might be trusting their bank because they're also trusting their bank with their bank account and putting it there. And so you get like this risk of the bus factor, right, of the death, like you can reduce it that way. But also like the way you can reduce it, you can, because it's smart contracts, right? You can deploy whatever smart contract you want. You can reduce the risk just by saying it's not 2 out of 3, but maybe it is 3 out of 5 or 4 out of 5, right? You can like play around with these numbers, increase them or decrease them, really depending on you personally or your business case. It's a total freedom, and there's nothing predefined by us, right? It's just like you define the smart contract.
Yeah, so I guess somewhat related is if especially in the earlier stages of rolling out these kinds of solutions, do you see like there can be edge cases where just something that hasn't really happened before, and you kind of have to like step in manually to curate something. Do you see that happening? Yeah.
I think that just what you said, like I think that users are not sensitized to like managing private keys today, right? This is clearly something that we see. So if you set up a MetaMask account, and MetaMask is trying to tell you like, you need to keep a backup of this, but we see that people like not from the blockchain space do not fully understand that. They think like, yeah, I see this always, right? But at the end of the day, I can still use email recovery. And people don't understand that they cannot do email recovery. Like if your private key is gone, there's a problem. So I think this is the biggest problem we're seeing. Our solution to that has been to tell like, get a hardware wallet, get a ledger wallet. If you feel like the customer cannot, like they're not technical enough, just get a ledger wallet. It's solving that as the biggest problem, because it makes it much more like a physical key, and then they also understand like they cannot lose this, and they will keep it secure. And at the same time, it keeps your solution secure.
Okay, cool.
The problem with that is, though, if I can say that, like the user interfaces become more complex, right? And the user experience becomes more complex, of course.
Yeah, it's always that balance between UX and security. Just checking in if anyone has any questions, and if you're too shy to ask them, feel free to DM me and I can ask for you. Yeah, so anyone feel free to raise any questions. I think we can take a couple more questions before we move on to the next section. One question I had was, so you mentioned earlier in the presentation of, I'm not sure if I'm pronouncing it right, Ngrok or Ngrok, where it's for decentralized websites. Would you be able to compare that maybe with IPFS, which I guess some of us would be more familiar with?
Yeah, sure. It is really 2 different systems. So in IPFS, the idea is you put some data out, right? Like some static data. It could be a website, or it could be even some files from the past. But it's always some data you publish. What we are doing with the decentralized website is actually like interaction. So it could be an auction site, for example. You have an eBay auction site. So you're not only consuming data and reading it, but you're actually writing it, something like an action. You say like, I want to buy, or you make a post, something that actually interacts in both directions. And so this is when you really use, it's much more like standard web technology. So anything that is web technology today, you can publish there. With developers, very popular, for example, is also SSH access, right? Which is just a remote access to a machine. So you have your light bulb or you have your IoT device like on the other side of the planet, and it doesn't have like a public DNS name. So you can use Diode actually to give it that. It gets this public name on the Ethereum, on the chain, and then you can connect to it with SSH. And that's something you cannot do with IPFS, right? Because it's IPFS is like a file protocol, but Diode is a direct connection protocol for bidirectional communication between two sites. Also, like a video chat, for example, a video stream, you can also do that with Diode. Like anything that is bidirectional and real time.
Okay. Okay, and I guess back more on topic. There's a question here on basically. So and I think this is quite common as well. Kind of question that people would have is if there's an IoT device and if the device itself gets hacked, how does the system sort of detect it and block it or prevent it?
Yeah, this is a good question, right? So there's probably a couple of answers to that. Like one is that we actually have seen a lot of devices being impersonated, and often the problem is that like devices don't talk encrypted, and often is that the platform of the device is being attacked, right? So at least that, like the platform of the device, we can protect because we're not using these public protocols. We're using end-to-end encrypted channels. But if it still happens, right, you still have some bugs and somebody is still able to hack the device, then the device is going to impersonate, in the worst case, have access to the private key of this single device, right? So in our model, like every device has like its own private key, and they all belong to a device fleet. That's what we call. And so we identify them that they belong to this device fleet, which is a smart contract. Now, if one of the devices is being hacked and starts acting strangely, you can just kick it out of the smart contract of the fleet device. And then once it's being kicked out, it loses access to everything. Like in that moment, because it's in the consensus in the blockchain, everybody sees like this device doesn't belong anymore to our fleet. It's gone and can't talk to anybody else anymore.
Okay, thanks, Dominic. So that wraps up Dominic's presentation. Thank you for sharing your knowledge. We will be going to the next section here of a discussion on decentralized social networks. And I think Dominic even mentioned some of that in as part of his presentation. And I'm sure everyone has a lot of opinions on the current social networks and the problems with them, and how potentially a decentralized version can and provide solutions for it. So I just putting in a link to a Google Doc here in the chat. So everyone, please feel free to come in there and add notes to it. And if you want to suggest any different subtopics to discuss, feel free to do that as well. I was just thinking as a general template, just to sort of start with what it is or what people understand the topic is, and what are some pros and cons of the current version versus any suggested solution. So yeah, if anyone wants to kind of give your opinion of what a social network is as it stands, and how a decentralized version of it can work, please feel free to bring it up. Otherwise, I'll come up with my own understanding and experience of it first. So social networks as it stands are websites like Facebook and Twitter. Obviously, we can use it to communicate with people around the world, but the problem comes in where it can be co-opted. People can put in fake news, and because humans are inclined to believe, there's this thing called confirmation bias, where we're inclined to believe something that agrees with our beliefs. So people stick to their own versions of truths, and end up in this warring situation with each other all the time. And there's also an element of sharing sort of information that is not safe, maybe morally, ethically, or even just from a national security point of view. So those are some of the problems with such social media as it stands. A decentralized social network theoretically can sort of get over any censorship that happens. And with the example of Steam, you can be even incentivized to add input, so that you drive people to add more opinions on these networks. There are probably a couple of people here who know a bit more on what happened with Steam. So if you know, feel free to add. Ray, do you want to elaborate a bit more on what happened with Steam? To my understanding, it was, I mean, first of all, there's a question of if you simply incentivize using just money, how far that can go, because money alone without elements of like reputation doesn't go very far. And with a blockchain that eventually can be bought over and be owned by a centralized third party, then it defeats the point of being a decentralized social network. So as a generalization, you could even say that even if it wasn't Steam, if it was any other decentralized social network, but if somehow it gets a 51% attack, then it can be corrupted. And we've seen with real chains, whether social networks or not, that a lot of times people don't necessarily care, and the value can even hold up even as it's been attacked multiple times. So yeah, does anyone want to add any thoughts on social networks, an introduction to current social networks and to decentralized social networks? Yeah, Paul, go ahead. You should be able to unmute yourself.
Yep, I think I just did. Can you hear me?
Yeah.
Good. Yeah, so I want to introduce another topic about decentralized social networks, and well, we as with everything in blockchain, we sort of have this part of where there's the logic and the data storage, right? And I think that's something very interesting in social networks as they work right now is that you actually go to somebody's house, to somebody's server, to let's say Facebook, and you knock at their door and you say, hey, can I have my own data that you're hosting for me? And they might or might not decide to give you access to this data, depending on whether they decide that you're a bot or that you are actually the person that you're saying that you are because you introduced the password, and they might let somebody else that actually has this password access this data that's yours, etc. And but not only this, but also they are in control of who else can see your data and who else's data you can see. And I think, I mean, that's just how it works, and it shouldn't be surprising at all. But it is important that we consider data storage part when we think about the centralized social networks, because it becomes really powerful to be able to be you who is able to give control to your own data to somebody else, and to revoke the access to this data. I'm just not going to say DAppNode, but DAppNode. But no, sorry. There's a social network built on top of Swarm or IPFS could be something that allows that would allow you to share your encrypted data in a decentralized way with whoever you want to share your data. So whenever you, so imagine that you basically have the skeleton, and that's the social network. It's like a wireframe, and you fill it with your own data, and then you're actually asking in the background to other people's servers or to other people's swarms or IPFSs. You can say, or other people's smart contracts, saying like, hey, where can I find the IPFS hash of your latest data, your latest update? And then you fill it you fill it if they actually give you access to this sort of thing. And that's something that I've been thinking about lately on the data storage part, because a lot of, I mean, that's the part that I've not been seeing or hearing so much.
I think one issue with IPFS as a sort of infrastructure for this is, at least in my experience, it's very difficult to find relevant links or items. Maybe there's just a UX thing that can be solved for, but as it is right now, it's a mess to find these things. Absolutely true.
Yes, it is a bit of a mess, and maybe it's not there yet in terms of usability. But something similar. I know the Swarm team, the B team is doing a great job towards that direction. It's something that they have in mind, and they're working with a data fund as well for sort of like fair drop and other solutions for sharing data, and give permissions and withdraw permissions to other people to share your own data. Of course, everything becomes a lot easier if you are hosting your own node, but there's ways of doing that and spreading, like putting sort of like where to find this information in a smart contract, so to speak, and then whoever has access to that smart contract, or whoever, or maybe the smart contract is public, but then you go to that address and you can only decrypt this data if you have a specific Ethereum key, or if you're a specific person.
Dave, did you want to say something?
Yeah. I mean, okay. I mean, we saw PPEth, which basically offered Twitter-like stuff, but did not, but is still struggling insanely. But I was actually had some other things to mention. Let's make myself visible. Can I see myself? Hey, I can see myself. I'm telling you how. Okay, so the things that I was thinking about is that, I mean, there are definitely pros and cons to making a social network decentralized. One of the problems that we don't like about Facebook is that people can game the system, right? The problem is any kind of incentive you try and put in place is equally gameable. So, you know, we all have an idea of what we deem acceptable and not acceptable on a social network, and they're all different, right? Now, you mentioned two things earlier on, really, which is like financial incentives and reputational incentives. I mean, I knew a guy who, you know, he would go to a restaurant and he would just park on the double yellow line outside because he didn't actually care if they fined him. The amount of the fine didn't mean enough to him. In any situation, you know, if you look at like the things Cambridge Analytica did, I don't believe that you could put a financial incentive in place that would make it not worth them doing what they did, because I believe
Dave, I think we're losing you. Dave, you need to unmute yourself.
Okay, I am unmuted. Okay, so I think that it's very difficult for financial incentives because you have to figure out. Yeah, I mean, like the things that would stop a small player from doing bad things, stop a big player, if they can see enough alternative advantages from messing with the system. And the same thing applies to reputation, really. I mean, we've got a couple of people in the space. I mean, Craig Wright certainly seems to be one of them. Justin Sun also appears to be one of them, who basically just don't give a damn. You know,
Dave, we lost you again. You need to unmute yourself again. You're good now.
You did. I have a horrible connection. It's all the way from JB. That's what it is. Yeah. Anyway, so I mean, I think it's hard to put the incentives in place. The only thing I could having community curated content list if you have a decentralized platform, because I mean, like, yeah, everybody wants something to be permissionless, to be uncensorable, and whether you're talking about child pornography or pirated stuff or whatever, you know, there's something that, you know, there are things that, like, you know, at least 99% of all people would not want on their social platform. So it gets quite complicated. And so, I mean, like, yeah, okay, community curated lists, just like, for example, on Uniswap, you can now choose your lists of coins. That's one possibility. Question, would you want to go into a network where your kids could pick up an alternative list and then access stuff that you really didn't think they ought to be accessing at their age? So there are lots of challenges. That's basically where I'm going with this. Decentralization, democratization is always a double-edged sword.
Yeah, and I think one very interesting that you mentioned early on was this whole idea of, I don't remember exactly what you said, hopefully I'm paraphrasing it right, but like different people essentially have different values, and the more I see of things in the decentralized world, and even, for example, not to touch on this very hot topic, but for example, politics in the US, where essentially someone's idea of what's right is another person's idea of what's wrong, and people just have completely different values. And so there's this phrase, good fences make better neighbors. So potentially any decentralized social network may want to kind of have a focus on, let's say their network only focuses on these are the values that we subscribe to, and these are some other values that we don't have an opinion on, whether it's right or wrong. And so to me, it feels like without that kind of structure, you will eventually run into a situation where people get very angry or unhappy at each other, not because they are intentionally meaning to be rude, but because their idea of what's right and wrong are just diametrically opposite. And so the network, if it just lets it run free, people will kind of clash on those things and try and get sort of popularity from other people who share the same opinions or values on this one point, and get into friction with another. I don't know if that made much sense, but like maybe one example is, and hopefully people can take this objectively, are things such as homosexuality, where in certain cultures it's or certain beliefs it's a big no-no, whereas in others they believe it's a human right, and without and I feel like anyone on either side will never be happy with the other on this particular point, and if the sort of network doesn't have any kind of guideline or rule or structure on how we want to approach this particular topic, then it will always be fractious and bad, because because people won't be able to agree on the rightness of that particular point. Then another thing that Dave mentioned was about curation with Uniswap as an example. This is to me very interesting. So Etherscan also has to curate a lot of stuff when it comes to let's say tokens to even lots of other details, and there's always this problem of like who watches the watchman. Like if there's any curators, then who decides on the curator whether they're right or wrong? And for example, with the Uniswap token list, for those who are not familiar, Uniswap recently kind of like opened it up so that other people can create their own lists. So whether it's CoinGecko or any other project can create their own lists for people to use. But essentially, instead of then Uniswap deciding what lists to get added, it's other people who are deciding. And then the question will be, who decides on these people, whether they are legit or not, to create their curated lists. And I honestly don't know whether there is a answer for that, because like with one of the questions asked to Dominic earlier, like there will always be edge cases, and especially when it comes to social things where it's not purely logic, and there's a lot of subjectivity involved. So who then, can you do something where there is no curator at all? And the opposite will be, if there's a curator, then who decides whether someone qualifies to be a curator or not? If anyone has any thoughts on any solution for that, that'd be very welcome. The only thing I can think of on my end is having that sort of pre-agreed values that the people in the network subscribe to, and values that they agree can we can have differences on. If there's anything else from anyone, happy to have you bring it up. Otherwise, we're essentially at the end of our time already. And yeah, if anybody has any points they want to bring up, feel free to. Otherwise, I'll end it here on the discussion on social networks. And there's a bunch of links that have been added earlier. I'll make sure to share it in the Telegram group later. And yeah, otherwise we will end today's meetup here. And the next meetup will be on the 5th of November, where we will have that note to present on what they do and what they're preparing for ETH2. And hopefully you can also have a discussion on staking in ETH2, whether people are looking forward to do that, any pros and cons of that as well. So yeah, thanks everyone for tuning in today. And thank you a lot, Dominic, for sharing your time.